So good morning everyone. I welcome you all back to the lecture series of electrical load calculation. So in this video, previously we have discussed about what are the classification of load and the classification of loads are resistive, capacitive and inductive load. We have briefly discussed about that. Then we move on to what is connected load and what is demand load. So now let's move on to the next topic, what is load factor. So in this topic we are going to discuss what is load factor, why it is important and how this load factor is calculated and why it is given so much importance and how this load factor make us to utilize the energy effectively and efficiently. So here the load factor express how uniformly a load is used over time and it is important for energy efficiency planning. The diagram or a simple screenshot or a picture what you are seeing on the slide is a bill of that is an electricity bill. So this bill indicate the usage value, that is billed kilowatt hour. The amount of power consumed by a consumer is calculated in terms of kilowatt hour. So the total kilowatt hour calculated is given as 39,835.65 kilowatt hour and bill demand kilowatt hour is given as 103.6 kilowatt hour. So don't worry about the difference between the used and demanded. We will discuss in this particular slide what is demand load and what is the load actually consumed. So here this consumption, in this consumption, so we have the classification of various building or various floor lighting. So here I have taken one small simple example, that is outdoor lighting, where the outdoor lighting consists of 10 different kinds of light and each have different quantities and power consumption. So the total of 1550 kilowatt has been used for outdoor lighting and I have encircled the load factor and it is mentioned in terms of 57.22%. So this is printed on a bill and this will indicate you how efficiently you are using the power on a daily basis. Let's move on to how to calculate this one. So to calculate the load factor for electricity, so it is the ratio of total kilowatt hour for the billing period by peak demand into number of days into 24 hours into 100. So for example, if you take the total kilowatt billing hour or the total power consumed is 36 kilowatt hour and the peak demand is 80 kilowatt, that is on which day the power has been consumed maximum, or how much power or the maximum consumed power in which days in the 30 days is taken as the peak demand, that is 80 kilowatt into 30 number of calendar days into 24 hours into 10. So here we have the final answer as 62.5 load factor. So if the load factor is increased, it means that we are effectively and efficiently using the power. So this is how the load factor is calculated and this is the load profile. So this is the graph, it shows a day profile. So like this we can also have a monthly profile and we can also have a yearly profile. So based on the requirement of the industry or the residential building, this profile can be modified. So here in x-axis we have hours mentioned in terms of 1 to 24, that is the entire span of a day. So this is 24 hours. In 24 hours how the load is being consumed for a residential building, and y-axis represent load in terms of kilowatt. So starting from 0 to 1 we have for the first hour of the day we have consumed 4 kilowatt. In the second hour it has been reduced to 2.5. In third hour it has been reduced to 1 and followed by 0.5, then it is gradually increasing. On the sixth hour it has been increased to 1, then followed by it reaches the maximum consumption at the hour of 18, that is it reaches around 15 kilowatt hour is being used. This is the peak demand or the peak load. So This graph clearly indicate at which hour how much load has been consumed by the consumer or the industry or the residential building. So this is how the profile is being drawn to ensure that whenever the load requirement is high and which hour we are consuming lot amount of the power. Or this graph also will make us to identify where we have to reduce the consumption, or whether according to the time we are consuming the power exactly, or we are deviating somewhere else. So for that inference, it will be very useful for notifying, or very useful to have a load profile like this. And let's move on to demand factor. So I already in the first slide we have said what is demand factor, and here is the demand factor. So it is nothing but the ratio of demanding other, that is maximum demand to the connected load. So the maximum demand, for example, it is 50 kilowatt and the connected load is, the sum of all the connected load is 25 plus 20 plus 8 plus 5, for example, then it comes around 0.86. So how to calculate demanding factor? First we have to sum all the connected load, that is 25 plus 20 plus 8 plus 5. You all know what is connected load and what is demand load. In the first class we have briefly discussed about that. Then apply the standard demand factor formula, that is maximum demand by connected load. So here the maximum demand is 50 divided by sum of the connected load will give you the demanding factor. So I hope this slide or this video has given a small idea on how to calculate load factor and demand factor, and why it is important to calculate them for effective usage of electricity. Thank you for watching.